So, what's your brain really up to right now? I don't mean when you're laser focused on a puzzle or listening to a song. I mean in the quiet moments, when you think you're doing, well, nothing. Turns out, your brain is never, ever off. It's running this incredibly complex secret symphony all the time. And today, we're going to tune in and have a listen. I mean, really think about it. You're just sitting there, maybe staring into space. Your brain isn't just idling, it's humming with this constant, powerful activity. For decades, neuroscience didn't really have an answer for what this hum was all about. To be honest, for a long time, they weren't even asking the right question. For years and years, scientists basically saw this constant background activity as, well, just noise. Like static on the radio. It was something annoying that you had to filter out to get to the real signals. But here's the kicker. They were throwing away the most interesting part of the whole story. See, the old school way to study the brain was pretty straightforward. You give it a job to do. Researchers would put someone in a brain scanner, an fMRI machine, and have them do a simple task, like opening and closing their eyes over and over, just to see which parts of the brain lit up. They were hunting for a really clean signal, kind of like the yellow and red spots you see here that pop up right when the task happens. But all that other activity, that messy-looking wavy line in the background, was just dismissed as random noise. In literally thousands of studies, this noise was just averaged out and completely discarded. But there was this huge, nagging question. If all that background activity was truly meaningless noise, why on earth was the brain spending a shocking amount of energy to create it? And answering that one question? Well, it changed everything. Okay, get this. Your brain is only about 2% of your body's weight, but it uses a whopping 20% of your body's total energy just at rest. Actually, doing a mental task adds less than 5% on top of that. That means the vast majority of your brain's work has nothing to do with reacting to the outside world. It's all about running its own internal show. This led to a beautifully simple and, frankly, brilliant experiment. Instead of trying to filter out all that noise, a few researchers decided to just listen to it. They picked one spot, a seed region in the left motor cortex, that's the part of your brain that controls movement, and they just recorded what it was doing while a person was lying perfectly still. And when we say activity, we're usually talking about something called the bold signal. It's a bit of a mouthful, blood oxygen level dependent. But basically, it's just an indirect way to measure brain activity. When your neurons fire up, they need more oxygen, so blood rushes to that area. More bold signal simply means more brain activity. Simple as that. And what they found was absolutely mind-blowing. The so-called noise coming from the left motor cortex wasn't random at all. Its activity was rising and falling in a perfect, spontaneous rhythm with the right motor cortex on the other side of the brain. Now remember, the person wasn't moving a muscle. This wasn't a response to anything. This was the brain's secret symphony, playing all by itself. This was the absolute game changer. The noise wasn't noise. It was structured. It was this coherent conversation happening between parts of the brain that do similar jobs. It was the first glimpse of a vast, hidden architecture that science was just starting to map. So once they knew what to look for, researchers could start to map this entire hidden world. And what they found wasn't just one or two networks, but a whole collection of them, all humming along, all constantly talking to each other. And this is the map they built, the brain's intrinsic architecture. You can pretty clearly see two major systems at play. Those warm colors, the reds and yellows, show the networks that fire up when you're focused on a task in the outside world. And the cool colors, the blues and greens, show what's called the default mode network, which gets active when your mind starts to wander. So let's break that down. The task-positive networks are your brain's get-stuff-done systems. They're on when you're paying attention, solving a problem, really engaged with the world. The default mode network, on the other hand, is your inner world. It's you daydreaming, remembering something from your childhood, thinking about the future, or just thinking about yourself. And what's wild is that these two systems are often fighting for control. When one is active, the other tends to quiet down. And it all really comes down to this one simple, beautiful rule. Parts of the brain that do similar jobs tend to chat with each other, spontaneously, all the time, even when they seem to be off the clock. The brain's most fundamental wiring is revealed in this constant resting chatter. Okay, so we've got this incredible map of the brain's inner world, but this isn't just some pretty background music. This internal symphony is actually setting the stage for every single thing you think and do. And this is the million-dollar question, right? It's one thing to say the brain's resting state is organized. It's something else entirely to say that this organization actually has a real, tangible effect on how we act and what we perceive from one moment to the next. And the answer is a huge, resounding yes. Take a look at that top waveform. It shows the brain's response to the exact same stimulus, a button press, over and over. See how messy and variable it is? The reason for that is the bottom waveform. That's the underlying spontaneous activity, which is always fluctuating and essentially adding itself to the task signal. And now for the really cool part. When scientists mathematically subtract that spontaneous noise from the messy task signal, boom, you're left with that beautiful, clean, super consistent signal on the right. This is proof positive that a lot of the variability in how we perform moment to moment isn't random. It's a direct result of the brain's underlying resting state. So what does this mean for you? Well, it means the state of your brain's motor network right before you press a button can actually predict how hard you're going to press it. If that network's spontaneous activity is already high, you might press a little softer. If it's low, you might press a bit harder. Your internal state literally shapes your external actions. Figuring out this intrinsic activity hasn't just solved some old puzzle in neuroscience. It has blown open a completely new way of understanding the brain, both when it's healthy and when it's not. So just how deep, how fundamental is this organization? Well, the image you're seeing right now shows the intrinsic networks of a monkey that's completely under anesthesia. And just look, the patterns are remarkably similar to those in fully awake humans. This is definitive proof that this isn't about conscious thought. This is the brain's bedrock, its functional blueprint. It's truly a core feature of how the brain is built. This intricate dance between networks keeps going whether we're awake, deep asleep, or even anesthetized. It's this constant, stable feature that really defines the essence of our brain's design. And the implications here are just massive. This opens up a whole new frontier for brain science. By studying these intrinsic networks, we might be able to diagnose diseases like Alzheimer's and depression much earlier. We can better understand how a child's brain develops, track recovery from a stroke, and maybe even start to get a handle on the mystery of consciousness itself. It has truly changed the game. So let's end with this one thought. We used to think of the resting brain as a quiet engine, just waiting for a command. But now we know it's this vibrant, self-organizing symphony, constantly working to maintain its own incredibly complex structure. Which really leaves us with a fascinating question to chew on. If your brain is this busy when it's at rest, what does rest even mean?